All right, guys, welcome to this page of the notes, and what we're going to do here is we're going to start our discussion on the second objective or learning target, which is graphing logarithmic functions. And some important things I want to go through here. Now remember, exponentials and logarithms are inverse functions. So what you're going to notice just looking at this table is you're going to be like, wow, that looks really similar to the exponential graph. And it should. They do look very similar, although they're kind of going in different directions, right? They should look very similar because they're inverse functions. And the similarities go beyond that. Remember, when we graphed exponential functions, all exponential functions without transformations went through the point 0, 1. Well, all logarithmic functions, as long as there are no transformations, every logarithmic function is going to go through the point 1, 0. Remember, when it comes to inverse functions, you switch the x and y value. Since exponentials go through 0, 1, logarithmic functions will go through 1, 0. You switch the domain and range value. So as long as there's no transformations, everybody's going through the point 1, 0, all logarithmic functions. Also, for exponential functions, the x-axis, if there were no transformations, the x-axis was always a horizontal asymptote. Well, for logarithmic functions, as long as there is no transformations, the y-axis is always going to be a vertical asymptote, right? You'll always have the y-axis as a vertical asymptote. So with that stuff in mind, let's go ahead and jump into graphing these logarithmic functions, keeping that stuff in mind. No transformations, you're going to go through the point 1, 0, and the y-axis, as long as there's no transformations, will be a vertical asymptote, which is a line that you will approach, but you should never, ever cross. Now, a couple other things about these as we kind of jump into them, and it's going to be this. When it comes to logarithmic functions, you must have 3 points. You can have more than 3 points, but I need a minimum of 3 points for you to plot. Must plot at least 3 points. So let's go ahead and take a look at how these work. Now, just like with exponential functions, I've given you the logarithmic function. We're going to set up an XY chart. We'll choose domain values smartly, but we'll choose domain values that we then plug in to get our range values. And here's how these are going to go. This is my function f of x. All right, so here's what I've got. I've given you the function f of x. It's log base 5 of x. Here's the 3 points that you're always going to choose, all right? We know that every logarithmic function without transformations has to go through the point 1, 0. Here's the reason why. It doesn't matter what the base is. Doesn't matter. This base can be anything, right? As long as I'm taking the log of 1. So log any base, 5, 10, 6, 20, 3, whatever. Doesn't matter what the base is. Log any base of 1. Log of 1 is always going to be 0. So that's why as long as there are no transformations, every single logarithm, regardless of what the base is going to go through the point 1, 0, because log any base of 1 is going to be 0. Try it on your calculator, right? Do as many of them as you need to satisfy yourself. I'm telling you the truth. The log any base, pick any base you want, of 1, you're going to get 0. And that's as long as there are no transformations. We're going to go through this point. So there's 1. I need 3 points. I got 2 more to go. And here's the easiest way to do these. Remember I mentioned at the beginning of this set of notes on the first page that anytime you take the log base and the augment, what you're taking the log of, and the base are the same, they'll cancel each other out. Since I have a log base 5, if I take the log base 5 of 5. So log base 5 of 5, the base and the augment will cancel each other out, and I'll be left with 1. So one of your points, you got to do 3 points. The first one, right, you're going to want to do a log of 1 because that's easy. It's always going to be 0 as long as there's no transformations. And you're going to want to do the log where the augment is the same as whatever your base is. Since my base was 5, I'm going to make my augment 5. The base and the augment will cancel each other out, and I'll be left with the 0.51 in this case. The other one will also be very simple. Since my base is 5, and I already did an augment of 5, the other easiest one is just to do the inverse of the base. Since my base was 5, the inverse would be 1/5. Now, 1/5, not so nice to graph. It's definitely a really small decimal, but that's okay. These are going to be the easiest 3 points to find, and so these are the ones that we're going to use. And again, you can do this as many times in your graphing calculator as you need to sort of satisfy yourself I'm telling you the truth, but log base 5 of 1/5 is always going to be a -1. If my base were 2, log base 2 of 1/2 is going to be a -1. If my base were a 3, log base 3 of 1/3 is going to be a -1, right? So that's why you must have at least 3 points, but the 3 points you're going to plot are going to be really, really easy points, and they're going to be dependent on what the base is. Whatever that base is, your first point, just do the inverse of it, you're going to get a -1. Whatever that base is, one of your points will be the same as the base, because then the base and the augment will cancel each other out, and you'll be left with just a 1, and then of course that tried and true 1, 0. Let's go ahead and plot my 3 points and see what this guy looks like. Okay, so I've got the 0.10, which is right there. I've got the 0.51, and I've got the 0.15 -1, which is going to be somewhere right about in there. Now I'm going to connect those dots with a nice smooth curve, remembering that the y-axis is always going to be a vertical asymptote, which is a line that I'll approach but should never touch. Now we're freehanding these graphs, so if you touch the y-axis, I'm not going to freak out at you, but please, for the love of all that is holy, do not cross that vertical asymptote. So you'll come right up through here. Make sure you extend your line the entire way through the coordinate plane. Put arrows on both ends so that I know you know it keeps going. And guys, based on the fact that we've already had experience graphing exponential functions, this should be like, wow, this is just like exponential functions. It just looks slightly different. And that's because they're inverses. Now let me show you something awesome. Remember, logarithms and exponentials are inverse functions. So I'm going to go ahead and do the good old snail method. And here's what I'm going to find. The inverse function would be 5 to the x power, right? If the logarithm is log base 5 of x, the inverse of that would be an exponential base 5 raised to the x power. These are going to be inverse functions. Well, let's go ahead and graph this guy, right? So I'm going to have my inverse function. Well, we've got lots of experience graphing exponential functions. All we have to do is choose a couple of points. Here's a couple of easy ones. I'm going to go ahead and do -1, 0, and 1. Now remember, these are inverse functions. The x and the y values, the domain and range values, switch places. Check this out. If for my function, my logarithm, right, if x was 1/5 and y was -1, those guys switch places for the inverse. So instead of 1/5 -1, I'll have -1, 1/5. The x and y switch places. And if you don't believe me, go ahead, throw this in your calculator. 5 raised to the -1 power, you're going to get 1/5. Same thing here. If I have 1, 0, the inverse, the x and y values will switch places. So instead of 1, 0, I'll have 0, 1. If you don't believe me, go ahead, do 5 raised to the 0 power. Anything raised to the 0 power is 1, and I get the point 0, 1. Keep going. I've got 5, 1. X and y values switch places for inverse functions. I'll have the point 1, 5. Again, if you don't believe me, plug a 1 in there for that. 5 raised to the first power is, of course, 5. Let's graph this function. I'll do this one in green. We have the point 0, 1. We have the point 1, 5. 1, 2, 3, 4, 5. I've got the point negative 1, 1/5, which is going to be somewhere right about there. Remember, for exponential functions, the x-axis is a horizontal asymptote. It's a line that you approach but never cross. So my exponential function, which we looked at graphing back in section 1, should look like this. Again, make sure you extend your line all the way through the coordinate plane I've given you. Put arrows on both ends so I know you know they just keep going. And let's talk about inverse functions. A couple of chapters ago when we talked about inverse functions, we said inverse functions are going to be mirror images of each other across the identity function. The identity function is a line that splits the first and third quadrant in half. It's this guy right here. So if you want a quick way to check and see, did I graph my logarithm correctly? Well, go ahead and graph the exponential function. Just a real quick look at that, and you can very easily tell, yeah, those are definitely mirror images of each other across that identity function, the line y equals x, which is the identity function. They're definitely mirror images of each other, plus the fact that I've found that the x and y values just switch places, which I know for inverse functions, the domain and range values switch places. All you got to do is switch the x and the y. So what I'm going to do for you guys as we move on to other example problems for graphing, I will graph both the exponential and the logarithmic functions so that we can see these inverse functions. I will ask you, if you're taking this class with me, to graph inverse functions. I'll give you the logarithm or the exponential and ask you to find and graph the other one. So you will be asked to do this in the free response section of my test if you're taking this class with me. So it wouldn't be a bad idea to just get used to doing it. But again, the key points here are this. You need at least 3 points to graph a logarithm, but they're very easy points to find, all right? It really is just dependent on whatever your base is. And then remember, your y-axis, as long as there are no transformations, that y-axis is going to be your vertical asymptote. You can approach it, but you should never cross it. And you'll go through the point 1, 0, right? Because my exponential goes through 0, 1. My logarithm will go through 1, 0. They're inverses of each other. Also, domain and range, just real quick here for this guy. Talk about the domain and range. Here's the way that the domain and range works. Please notice the logarithm, right? My logarithmic function does not cross the x-axis. That means, and again, feel free to try as many of these on your graphing calculator or on your calculator as you want to. You cannot take the log of a negative number. And the reason is because I have a vertical asymptote that is restricting my domain. Right? I have a vertical line that I cannot cross. And that vertical line is going to keep me from taking the log of a negative number. So my domain, because my y-axis is my vertical asymptote, my domain is only going to be positive values of x. So all x strictly greater than 0. Right? Strictly greater than 0. I cannot take the log of 0 or a negative number. And that's why I have a vertical asymptote restricting my domain. But please notice now for the range, right? For the range, all values of y are possible. All real numbers. Now guys, take a look at this. This is awesome. Hopefully, if I haven't already done so, right, this hopefully should be blowing your mind, right? They're inverse functions. think about what's the domain and range for my exponential. Well, it's the exact opposite. For my exponential, the domain was all real numbers, right? And remember, for inverse functions, the domain and range switch places. Because my domain is all real numbers for my exponential, for my logarithm, the range will be all real numbers. Domain and range switch places. And then for the range, remember, right, the x-axis is my horizontal asymptote. That's the line that I can't cross. But everything above that is okay. All y values greater than 0. Take a look at this. My exponential is all values of y greater than 0. My domain is all values of x greater than 0. Guys, these inverse functions are absolutely amazing. There's a ton of stuff I can ask you to do with them. We'll get more practice as we go on with a few other example problems. So head on over to the next page in the notes. We'll take a look at a couple more of these, and I'll really kind of drive these points home because I know I just gave you a lot, but it's a lot of fun. So I'll see you guys on the next page.